Hi, Miguel. I'm gonna do 11 and 13. Sorry, I didn't see your email until just a few minutes ago. So let's look at this 11. We've got this is our polynomial function. And it says find the intervals where it's increasing or decreasing, find the local max and mins, find the intervals of concavity and the inflection points. Okay, so to find the intervals where it's increasing and decreasing, we want to take the derivative. You get 4x cubed minus 4x, and then you set that equal to 0. Now I can factor out 4x from both of these, and I'm left with x squared minus 1. And so this gives me x equals 0. This gives me x is equal to plus or minus 1. So those are my critical numbers. I'm going to come over here and put them all on the real number line. 0, 1, and negative 1. And let's see, f prime. Now I need to pick a test point in each of these places. Over here I'm going to pick, let's see, I guess I'll pick 1/2 and negative 1/2 in these two intervals. Now in this interval over here, I could pick 2, but I'm going to pick 10 because I think it'll be easier to plug in. And ditto back here, I could pick negative 2, but I'm going to pick negative 10. So let's do this. All right, f prime of negative 10. I'm plugging negative 10 back into f prime. I'm gonna erase my 0 there. So f prime of negative 10 is going to be 4 times negative 10 cubed minus 4 times negative 10. And if you look at that, that's negative 4,000 plus 40, so that's definitely negative. If I plug in 1/2, or if I plug in negative 1/2, let's see, that's 4 times negative 1/2 cubed minus 4 times negative 1/2. So let's see, 1/2 cubed is 1/8. So this is 4 times minus 1/8 plus 2. So let's see, this is negative 1/2 plus 2. So that's positive. All right, if I plug in just 1/2, that gives me 4 times 1/2 cubed minus 4 times 1/2. Let's see, this is 4 times 1/8. So that's 4 over 8, which is 1/2. And then minus 2, so that's negative. And if I plug in 10, and these should all be primes. I'm plugging into the derivative here, not the original function. I'm plugging into the derivative. So if I plug in f of 10, I get, let's see, 4,000 minus 40. So that's definitely a positive number. So this tells me that the function is decreasing. Because remember, this is the slope. If the derivative is negative, the function's decreasing. If the derivative is positive, the function's increasing. All right, so this tells me that the function has this sort of general shape. So that tells me that it's increasing on, let's see, this interval here from negative 1 to 0, and on this interval over here from 1 to infinity. And it's decreasing on minus infinity to negative 1, and over here from 0 to 1. And let's see, infinity always gets a parenthesis, so let me rewrite this parenthesis there. All right, so that's part A. Part B says find the local maximum and minimum values. All right, so you can look at the graph over here. We've got a minimum here, a maximum here, and a minimum there. So we have a local minimum of blank at x equals -1. A local minimum of something else at x equals 1. And a local max of something at x equals 0. Now, the way we get what the minimum and maximum values are is by plugging these numbers here back into the original function. Oh, wait, the original function. So if we plug in 0, I'm going to plug that one in. Plug 0 into here, you get 3. Excuse me. If you plug 1 in, let's see, you get 1 minus 2 plus 3. 1 minus 2 plus 3. That's 4 minus 2 is 2. And if you plug -1 in, you get, let's see, 1 minus 2 is -1 plus 3 is 2. So this is the answer to B. And then C, it says find the intervals of concavity and the inflection point. So for C, we need to take the second derivative. Let's see, f double prime of x is going to be 12. You know, that's the derivative of f prime. So it's going to be 12x squared minus 4. I'll set that equal to 0. You get 12x squared equals 4. So this is going to be 4 over 12. So x is plus or minus square root of 4 over the square root of 12. Now let's rewrite that square root of 12 as square root of 4 times square root of 3. Now I could simplify those, but I'm just going to cancel them. So get x is plus or minus 1 over root 3. All right, I'm about out of space. Well, I'll go to the next page. So for concavity, I'm going to put on here my two hypercritical numbers, minus 1 over root 3 and positive 1 over root 3. Now I got to pick numbers that are in each one of these. So this is 0 here. 1 over root 3. Square root of 3 is 1 point something. It's bigger than 1. So that means this number is less than 1. So I can pick a 1 here for this test value and a -1 here. And then if I look at f double prime in each of these intervals, f double prime of 0, if I plug f0 into here, I get -4. If I plug in 1, I get 12 minus 4, which is positive. And if I plug in -1, I also get the same thing, so it's concave up here and concave down here. So my intervals of concavity, to make this short, I'm not going to write them out, but the intervals of concavity would be concave up from -infinity to this number, concave up from 1 over root 3 to positive infinity, and concave down in the middle. And you'd have an inflection point at x equals -1 over root 3, and another one at x equals 1 over root 3.